So see this, what is given in that numerical, an iron ring. So the first thing is that a one iron ring we have to consider. Suppose let me consider that this is a one iron ring 50 centimeter in a diameter. Now the diameter of this iron ring is given as a 50 centimeter. So what you can calculate by using this diameter? The circumference of that ring. Is it right? Or the length of that ring, you can calculate it. 10 centimeters square in a cross section. Now this iron ring having that area of cross section A. So here I can write D is equal to 15 centimeter. D stands for diameter of the ring. A is equal to 10 centimeters square. Okay, cross section is wound with the 200 turns. Now this ring is entirely wound with a coil. बट आय हॅव जस्ट शोन म्हणजे मी इथं फक्त त्या कॉईलचा काही पार्टच दाखवतोय, बरोबर आहे. परंतु तुम्ही असं अज्युम करायचंय की ही रिंग या कॉईलनं पूर्णपणे वाउंड केलेली आहे. सो हिअर द नंबर ऑफ टर्न्स इज गिवन अँड दॅट एन इज इक्वल टू 200 टर्न्स. इज इट राईट? फॉर अ फ्लक्स डेन्सिटी ऑफ 1 वेबर पर मीटर स्क्वेअर, व्हॉट इज गिवन? 1 Weber per meter square. What is this? Diksha Annadate.
Yes, sir.
How I don't know, but why that two logins I observed here with your name A01 Diksha Annadate?
हा सर मलाच कळणे आता एकदम बॅकला पडलीये.
Now it's okay. Now it's okay. Okay. So what is given? This 1 Weber per meter square. What is this?
Flux density.
How
B.
we can denote it? It's a B. So here that thing you must know now. 1 Tesla. I can write it down because SI unit of a flux density is a Tesla. 1 Tesla is equal to 1 Weber per meter square. So I can write it down. It's a, in terms of Weber per meter square, I can write it down Tesla. Assume the relative permeability of an iron means mu R, which is equal to 500. Okay. फॉर द आयर्न अँड निग्लेक्ट लिकेज अँड फ्रिंजिंग. आता एवढा काय याचा विचार करू नका कारण आपल्याला निग्लेक्टच करायला सांगितलेलं आहे. याच्यानंतर आपल्याला काही थिअरॉटिकल पार्टमध्ये नाऊ वी आर देन वी विल कन्सिडर दॅट द लिकेज अँड फ्रिंजिंग. सो व्हॉट वी हॅव टू फाइंड आउट? नंबर 1, reluctance of the ring. So here I say that S. Number 2, MMF. Its a formula is N into I. Number 3, MMF required for that iron. Oh, sorry. Number 2 is a flux. Oh, no problem. I can write it on 3 as a flux. Then MMF, and then fourth one is exciting current means I. These things we have to do. So the first thing is that they have provided that the diameter of the ring, and now you can try to imagine when the wire, when the coil, if it is entirely wound on that iron ring, then this complete circuit acts as a solenoid coil. This complete circuit, it acts as a solenoid coil, and the expected path inside the solenoid coil to flow the flux is shown with the dotted line. This is the expected path of a flux. And this expected path of a flux, which is nothing but the length of the ring. लक्षात येते? आता असं अज्युम करा की एक आयर्न रिंग आहे आणि ती रिंग कंप्लीट 200 टन्स न वाउंड केलेली आहे. We know that in terms of solenoid coil, magnetic field inside the solenoid is a strong and outside the solenoid is a practically zero. आता जर इनसाइड द सोलेनाइड म्हणलं तर ती सोलेनाइड कॉइल ही त्या आयर्न रिंगच्या भोवती वाउंड केलेली आहे. म्हणजे आयर्न रिंगची जेवढी लेंथ असेल तेवढा मॅग्नेटिक पाथ असेल. ती रोल नंबर 57, रोल नंबर 57 ज्ञानेश्वर मेत्रे. So this length of that iron ring, which is nothing but the length of the magnetic path, हे लक्षात येणं गरजेचं आहे बघा. And for that we will try to calculate the length. Now if I want to calculate that the length of this iron path by using the diameter, which formula you can use it? How you can
2
calculate that?
2 pi r.
It's a 2 pi r. Now here the diameter is given, so can I use that pi d formula here, because 2r is nothing but the diameter. Get it, my friend? So I can write pi multiplied by d is 15 centimeter, means centimeter is nothing but -2. Now don't use that the value of a pi is 3.14. The pi button is already there on your calculator. Please use that button. And then try to multiply with the 15 into 10 raised to -2 and give me that the length in terms of meter. Huh.
0.471.
0.471 meter. Now keep this answer on your calculator as it is, because it is required for the further calculation. Now first, what we have to calculate? Reluctance S. What is the formula? L divided by mu 0 mu r a. Let's we try to calculate 0.471. This is a numerator term, and the denominator is 4 mu 0. What is the its constant value? 4 pi into 10 raised to -7 multiplied by mu r. It's a 500. A, it's a 10 centimeter square. So it is given in a centimeter square. So can I convert it into meter square? So 10 into 10 raised to -4 meter square. So now you can give me that the value. This answer is on I think on your calculator, divided by, take one bracket, type the denominator as it is, complete the bracket, press the is equal to, you will get that S value. Yes, please.
Seven four nine six one nine point
749
619
619.7.
point 7.
What is the unit? Yash. हा प्रॉब्लेम आहे बघा. अजून पण तुम्ही लोक मी सांगून सुद्धा युनिट वरती
Ampere turn per Weber.
ampere turn. Always give that focus towards that the unit and that formula. Okay. Now second point, what we have to calculate? Flux in the ring. Now how you can calculate that the flux? If you want to use that basic formula, phi is equal to Ni upon S. Out of that, yes, you know that, but you don't know that the MMF. It means that you cannot use that formula. Is there any another formula to calculate that phi with the given data? Please check it. We cannot use this one formula. Phi is equal to MMF upon S. यातला येस माहित आहे, परंतु MMF माहित नाही आपल्याला, आणि MMF काढता पण येत नाही कारण आपल्याला करंट माहित नाहीये. आता त्याच्याऐवजी कोणता दुसरा फॉर्म्युला यूज करू शकतो बघा? इज देयर एनी अनदर फॉर्म्युला?
Equal to phi by a. Flux density equal to phi by a.
Absolutely correct. So we have that according to the definition of a flux density, B is equal to phi upon A. Is it right? So I can write phi is equal to B into A. Now B is 1 Tesla into area of cross section is 10 centimeter square. So I can write 10 into 10 raised to -4 meter square. So that phi is equal to 10 into 10 raised to -4 Weber. This is the value of phi. Is it that clear? Then the third thing, what we have to calculate? MMF required for that iron ring. आता MMF चा फॉर्म्युला जरी आपल्याला माहित असेल n into I, तरी I आपल्याला माहित नाहीये. Then how you can use it? Now you can use that our basic formula. Phi is equal to MMF upon reluctance. So I can write MMF is equal to phi into S. Now the phi value, it is already there on your calculator, which is 10 into 10 raised to minus 4 multiplied by S value 749,619.7. Type this value and give me that answer.
749.61.
749
Point
point
619.
619. Okay, correct. It's a unit is ampere turn. MMF the unit I ampere turn. And then fourth one is, as we have to calculate that exciting current, so we use that MMF is equal to N into I. So this is 749.619, which is equal to N is a 200 into I. So that I is equal to 749.619 divided by 200. So that I is equal to
3.748.
748 ampere. Is there any problem, any difficulty, any confusion? If not, please take a note of these things. Now please check it here. What is that numerical? A steel ring of cross-sectional area. Now here in place of iron ring, now the steel ring is there. Suppose I consider that this is a one ring. Okay. Its area of cross-section is given, is this one. So here I can write A is equal to 6 centimeter square. And the mean diameter, the diameter is given, it's 11 centimeter. So here I can write D is equal to 11 centimeter. Is wound with a 1200. Complete जी ring आहे ती 1200 ना wound केलेली आहे. So here I can write N is equal to 1200. An exciting current I, त्या कॉइल मधून फ्लो होणारा करंट हा I ची व्हॅल्यू दिलेली आहे. किती दिलेली आहे? 500 मिलीएम्पियर. Okay. Produces a flux. When the current it will be flow, as you know that this is the expected path of a flux phi. So that phi value is E1, and that value, one minute. It's not working. Is equal to 1.44 milliweber. That value is given. Okay. In the ring, calculate the relative permeability mu r. We have to find out. Now, if you check it, what the given data is provided, that n number of turns and the current is provided. So, can you calculate that MMF? Of course, yes. Phi value is given. So, we can use that formula, phi, basic formula, phi is equal to MMF upon reluctance. So, we can calculate that reluctance, and the reluctance is nothing but L divided by mu 0 mu r A. Based on that, we can calculate that mu 1. Okay. So, the first thing is that with the help of this diameter, we will calculate that the length of that magnetic path, and that formula is pi d. So here I can write pi into Diameter is 11 centimeters. So 11 into 10 raised to minus 2. Will you please give me that value of L? Ah, give me that value.
0.345.
0.345 meter. Okay. And then we use that basic formula. Phi is equal to mmf. Oh my God. mmf upon reluctance. This is my basic formula of a magnetic circuit. So I can write here reluctance, which is denoted by S, which is equal to mmf Ni upon phi. Now N is 1200 multiplied by current is 500 milli. Milli means 10 raised to how much?
Minus
Divided by phi is 1.44 milliweber means 10 raised to minus. So can you give me that? What is that value of S?
Four one six
एक मिनट मला आवाज का
41
बारीक यायला एक मिनिट
416 666.
once again will you please repeat?
Yes, sir.
416
416
666.
आता हे 6 झाल्यानंतर पुन्हा 666 का?
हो सर.
म्हणजे
Yes,
टोटल
sir.
4 times 6
Yes, sir.
0.66
point
66.
67 ampere turn per weber. Okay, and now we have that formula S is equal to L divided by mu 0 mu r a, and what we have to calculate? Mu r.
Mu R.
So I can write L divided by mu 0 a s. Now what is that value of L? Which is 0.345. Is it right? This is in bracket, and the denominator part is in bracket 4 pi into 10 raised to minus 7 into area of cross section is 6 into 10 raised to minus 4 centimeter square into S is 4 times 6.67. Give me that value of mu.
Sir, 10
1098.169.
1098
.169.
169. What is the unit? कौन सांगू शकते?
unitless.
Absolutely correct. It's a unitless quantity, and this is the answer actually. Expected answer is this one, but no doubt we have that the correct answer here. Is it right? Okay. So please take a note of this. Here, let me write the given data only with this numerical. Here, a steel ring of cross-sectional area A is of 5 centimeters square, and the mean diameter D is of 10 centimeters. Is wound with N 1300, and exciting current I is of 450 million. Produces a flux Y is equal to 1.5 milliweber. So what we have to find out? You have to calculate number one, reluctance, which is denoted by the letter S. And second thing is the relative permeability. That is nothing but mu R. Okay. So first, you use that basic formula, Y is equal to MMF upon reluctance. So that S is equal to MMF upon Y, which is equal to Ni upon Y. That is nothing but 1,200 into 450 into 10 raised to minus 3 divided by Y is 1.5 into 10 raised to minus 3. So definitely you will get that certain value. That unit is ampere turn per volt. And the second thing, first we have to calculate that length, which is nothing but pi d. Pi into diameter is 10 centimeter. Okay, so you have to calculate that length, which is a meter. And you use that formula S is equal to L divided by mu 0 mu R A. So you can write mu R is equal to L divided by mu 0 A into S. This is in bracket, this is in bracket, and I want that final answer for this mu. The same example is there. That's why I have given this for numerical for to you. Solve it and give me that final answer. सुतार अनुसार सुतार, please unmute yourself. Ansar Sutar. Nanishal Maitre.
Yes, sir.
Why that in between the lecture that your mic is on?
सॉरी सर, माझा मोबाईल हँग होतोय सर, त्यामुळे ते
Hang
गरम
होतोय.
झाल्यामुळे
ठीक आहे,
गरम
ठीक आहे.
झाल्या
ठीक आहे, ठीक आहे, ठीक आहे. राहू दे. सांगा आता मला. What is the value of yes? Nanishal Maitre. Have you calculated that value of yes?
करतोय सर.
एवढा वेळ? Okay, I will check that answer. पृथ्वीराज साठे. पृथ्वीराज साठे. May I talk with Prithviraj Sate?
Yes, sir.
What is that answer?
Calculation चालू आहे.
पृथ्वीराज साठे, मला तुम्ही या एस चा आन्सर आताच्या लेक्चर मध्ये देणार आहात. ठीक आहे. सुतार आन्सर आहेत का इथं? हॅलो, नाही मी जरा काही विद्यार्थ्यांना बघतो की काय करतायत का उगा आपलं अटेंडन्स साठी जॉईन झालेत. रणजित सरवले, रणजित सरवले असं जर असेल तर मग प्रत्येक लेक्चरलाच विचारतो आता मी प्रत्येक.
येस सर.
हा, काय आन्सर आलं येसचं? कॅल्क्युलेटर घेतलाय का रणजित?
नाही तर बँकेत आलो जर.
तुम्ही बँकेत आहे का आता?
हा
मग बँकेवाले पैसे कॅल्क्युलेटर असते की.
हा